Can you guys hear me back there? Good over there? How about over here? Can you guys hear me? Awesome. So, welcome. Backdooring Git. Before I start, let's get some legal stuff out of the way. The views and opinions expressed here are my own and no way represent the views, positions, or opinions expressed or implied by my employers, future, past, and present. And besides, I can also change my mind. So, thank you guys for coming. It's really awesome to see more than 20 people here this early in the morning. Hopefully the party last night was pretty awesome. I never did hear where the after party was, but since I don't see a few people who are really looking for that, I suspect it went way into the hours because I looked at my Facebook feed and people were still going strong at 6, 7 a.m. So I'm like, okay, I'm not going to see you this morning. But yeah, I'm John Menerick. I do fun things at NetSuite. I'm a security dragon there. And we get to break into stuff. We also get to build stuff. And a long time ago, started looking at Git and just realized, wow, there's not a lot of information on there on the offensive side, but also on the defensive side, not much there. Which is fine, you know, it is what it is. So I thought I'd just, you know, kind of share this with you guys, and hopefully you guys will get a few ideas to help take it on white hat or black hat side. So we'll be pretty much talking about backdooring Git. As you might imagine, we're not really going to be talking about the entire software development lifecycle or the variations, say, of SourceForge. Oops, by default, you know, backdooring executables with what some people would label as malware, but others would label it as advertising features and sales and profits. And as you might imagine, I could sit here and talk for hours, but all the different source code management solutions out there. But Wikipedia has a pretty good page. I'm sure there are flame wars on par with is Windows or Linux better? But for the most part, just go there, take a look. And then lastly, functionality versus backdoor. Really depends on your point of view. For instance, we have an email going to the OpenBSD list way back in the day, where this individual who was contracted to work on crypto functionality for the OpenBSD project, but in particular, the VPN setup, which is used widely everywhere. You guys might remember it as OpenVPN. He was like, hey, my NDA deceased with the FBI. By the way, they paid myself and others to introduce backdoors, a week in crypto, you know, in that project. Here are the developers. Take a look at their commits and review it. So some people would be like, hey, that's a backdoor. FBI and others would say functionality. So for argumentative purposes, just think of the same as a negative outcome that you do not want. So the interesting part is, when I was looking back in the day, which SCM should I pick? What should I really poke at? You know, it helped me because there wasn't really anything really useful out there. Tom Cruise, you know, as you might imagine, wasn't very helpful. But one of the things I realized immediately early on was there are the right tools for the job. There's also the wrong tools for the job. And by the wrong tools, you might imagine these Top Gear presenters will show us something that isn't so nice. And then hopefully we can get the audio working. Oh dear. Imagine how I tear down a house.
That felt nasty. What happened then?
James crashed into the corner of the house, and now basically you've got a whole house on your head.
Engine running.
May then winched Hammond's tank out, but Hammond himself was still trapped inside. Happily though, because I'd finally house-trained my machine...
Walkies? Yes, good digger.
I was able to mount a rescue.
Bad digger.
Oh, I've scratched my tank.
By now, the professionals had pulled out an enormous lead. So, to try and catch up, I decided to dig even deeper into the military toy box.
Guys,
What on earth is that?
I'll put some explosives in the house. You might want to stand back, as I'm now going to do the long walk.
Is that the suit or his piles that's making him walk like that?
Fire in the hole!
You've only blown the bloody door off!
After that failure, we decided just to use our machines as battering rams.
Come on, let's just get this job done.
Yeah. Using military vehicles to start ramming into buildings? Probably not the right tool. But as you might imagine, when you have a hammer, everything's a nail. So you're like, hey, let me start doing office documents and things like that collaboratively. Well, people would use a wiki. Some people actually try to use revision control software, but in particular, source code management, or SCM for short. That's meant for handling source code, not documents, not binary files, not images or artifacts or movies or extremely large files. So they made all the right choices for source code and small pieces of text, not gigantic files. And only recently could get handled adequately, 2-3 gig files and items of that sort. But the interesting part when I started digging further into it deeper was that there were mainly two different process models or workflow models. You had the traditional one source of truth, the gateway, the enforcer. Everyone had to interact with it. So if you're on the other side of the world, too bad, so sad, your traffic has to go all the way to the other side of the world, communicate and push and pull, which, okay, fine. But if you're constantly refreshing, downloading gigs at a time, that's not really acceptable. So people started going more to a distributive model, where people could push and pull from each other in a very hippie commune fashion, not necessarily the centralized source. It was really actually useful for quick prototyping and more agile development, or hey, let me push this feature to you, take a look, tell me what you think. And you look at kind of the Google trend history of the more popular modern SCMs, you see CVS in 2004, top dog, and then it just declines to a slow, poor death. And then you see kind of right there in green, kind of growing up, is CVS done right, or i.e. SVN. And, it was popular in 2006, 2007, and then just has been dying off. The commercial Perforce setup, popular for older institutions, it never really got anywhere, but it didn't really die as well. Meanwhile, Git it's been exploding, going on and increasing. So it seems like just beyond the Bay Area, Git's a pretty popular SCM out there. So I figured, hey, let's have some fun. So the problem is, what is Git? I've never been able to find the name of it, but there are generally two accepted names for it. Global Information Tracker if you're very happy, but if you're not happy with Git, because it does break, goddamn idiot truckload of shit is the other one. And the reason why I bring this up, because when it breaks hard, or it breaks in ways that would just mangle stuff and you would have no idea what it meant, or it's not very friendly to that aspect. So if you might imagine Hitler trying to use this, he gets really mad when it breaks for his cancer cure. So let's see what happens.
Es ist dem Feind gelungen, die Front in breiter Formation zu durchbrechen. Im Süden hat der Gegner Zossen genommen und stößt auf Stahnsdorf vor. Der Feind operiert jetzt am nördlichen Stadtrand zwischen Frohnau und Pankow, und im Osten ist der Feind bis zur Linie Lichtenberg-Marsdorf-Karlshorst gelangt.
Mit dem Angriff Steiners wird das alles in Ordnung kommen.
Mein Führer, Steiner konnte nicht genügend Kräfte für einen Angriff massieren. Der Angriff Steiner ist nicht erfolgt.
Es bleiben im Raum Keitel, Jodl, Krebs und Burgdorf.
Das war ein Befehl! Der Angriff Steiners war ein Befehl! Wer schickt Sie, dass Sie es wagen, sich meinen Befehl zu widersetzen? Oh, weit ist das also gekommen. Das Militär hat mich belogen. Jeder hat mich belogen, sogar die SS. Die gesamte Generalität ist nichts weiter als ein Haufen niederträchtiger, treuloser Feiglinge.
Mein Führer, ich kann nicht zulassen, dass die Soldaten, die für Sie verbringen...
Nicht als Feiglinge! Verreiter, Versager!
Mein Führer, was Sie da sagen, ist ungeheuerlich.
Die Generalität ist das Geschmeiß des deutschen Volkes. Sie ist ohne Ehre. Sie nennen sich Generale, weil sie Jahre auf Militärakademien zugebracht haben, nur um zu lernen, wie man Messer und Gabel hält. Jahrelang hat das Militär meine Aktionen nur behindert. Es hat mir jeden nur ersichtlichen Widerstand in den Weg gelegt. Ich hätte gut daran getan, von Jahren alle höheren Offiziere liquidieren zu lassen, wie Stalin. Ich war nie auf einer Akademie. Und doch habe ich allein auf mich gestellt, ganz Europa erobert. Verräter! Von allem Anfang an bin ich so verraten und betrogen worden. Es wurde ein ungeheurer Verrat geübt am deutschen Volke. Aber alle diese Verräter werden bezahlen. Mit ihrem eigenen Blut werden sie bezahlen. Sie werden das saufen in ihrem eigenen Blut.
Bitte gerne. Jetzt beruhig dich doch.
Meine Befehle sind in den Wind gesprochen. Es ist unmöglich, unter diesen Umständen zu führen. Es ist aus.
So imagine if Hitler's that mad for Git breaking functionally, imagine the confidentiality or the integrity or hell, even the availability aspects of Git. Git's pretty sad. And the interesting part about Git is Hitler, if he was using it with some semblance of sanity, there wouldn't be this one traditional source of truth where, okay, now we can't get to that server, but instead you have multiple copies all over your infrastructure. So for functionality development purposes, that's great. On the other hand, for developers, it's a very target-rich environment because all the attackers will be going after, instead of just X, Y, Z in scope, now the scope is gigantic. I only need to get one of them who has a misconfigured server or unpatched system rather than just the source of truth that is guarded by guards and other physical controls. Because the interesting part about this distributed nature is you end up with this ring of trust, whereas the world revolves around me, it also revolves around you. And there are people that I trust, and there's people that they trust, and goes on and on and on. And you start dealing with the security aspects of development. There's this pretty awesome quote where if you've ever done any security work, and it did not involve the concept of network of trust, it wasn't security work. It was shit. But trust me, it's the only way you can do security. It's the only way you can do development. Now, for $40, can someone tell me who said that? Here's a hint. It's not Steve. It's not Bill Gates. But he also said software is like sex. It's better when it's free. Who said Linus? I'll hunt you down afterwards. So yeah, Linus Torvalds. We see a picture of him in front of a pirated Windows 7 shop, and shaving the beard off a smug Unix user. The interesting part is, with the distributed natures, you don't want to give everybody right access to the central repository, because he says, most people are morons. So you end up creating this class of people who are not morons. Most of the time when that happens is you make that class too small, and then it's really hard to know if a person is smart or not. And then if you make it too small, people will have problems like, hey, this person went on vacation. So just to solve it, everyone gets commit access. Yay! But unfortunately, it's a huge psychological barrier and endless hours of politics within the organization and also within the open source communities as well. Because you end up typically with the traditional flow model if you have this one source of truth. And you have all your developers and QA engineers and others who pull from that source of truth. And then they'll push up to their dev leads or QA leads, and they'll do their own checks and balances there. And then if it passes everything, it'll go to the executive or the release team or DevOps, the dictators, and then they'll be like, yep, and go ahead and push on in. And it's this model which makes it very attractive to exploit, because you can just handle someone down at the bottom of that totem pole and just hope it squeaks on by trying to break in. So the interesting part is I started looking for backdoors. In the private sector, people trying to backdoor software through repositories. Sure, there's many instances of this, but in the open source or public sector, very little. What we see here is 2003, not the main Linux repositories, but a CVS repo that they had set up for CVS lovers. Had a very interesting change list. It doesn't look too benign, but in the very core Linux kernel wait function, hey, do some flags. If so, give them root privileges, right? Kernel mode. That's very sketchy. And when people started to look at the history for this, there were no comments about the commit, or the only one that was semi-legitimate but still not was, oops, I worked on the wrong file. Fixed it. So they go to that person called Dave M. Why the hell did you do this? If a program has the right flags compiled into their program, they run as root. You might imagine that's quite useful if you gain local access. But Dave M swears up and down that it wasn't him, so please people step forward. Then it got slash-dotted out of hell and back, and then yeah, it got pretty bad. But the interesting part is you look more into now, there's really not that many, or they have been attacking the repositories, but not the technology itself, but the implementations or out-of-date software. One of my favorite ones that I love is GitHub. That was pretty funny because this researcher found this default behavior in Rails where, hey, I could start changing attributes and settings for any Rails app that's running with this default setting turned on. And I can manipulate it and pretty much do what I want. And the Rails community was like, meh, it's a default setting. People can turn it off. And then he retorted back, okay, sure, but GitHub did it, Scribd and other popular, Rails apps, and they're like, meh. So security researchers stereotypically do not have the best social skills or problem solving. So he went straight to GitHub, to the Rails repo, and just said, yeah, look at this. Really? I can commit a master. And all he did was find one of the keys for those who had commit or push access to GitHub's Rails repo and just put his own in there. And then off he went. So the interesting part is just kind of sit back for a minute and think of a fun story time where my manager comes up to me and says, hey, John, how are you doing? And I'm like, okay. Hey, did you finish your TPS reports? And I'm like, no. Good, because you introduced a buffer overflow very blatantly into our source code. And I'm like, no, I didn't. What do you mean? So we pull up my repository and we look at the change list, and yeah, straightforward, simple as can be, a buffer overflow introduced into our repo. Okay, when I look at the repository, yes, that's me, I'm touching it, and then suddenly Steve Jobs or Steve at apple.com did something. And I'm like, he's dead. There's no way he did it. And then when I look further along, wait, 2015, 2008, 2015? Like, no. It's almost like this repo was time traveling. It made absolutely no sense. So I'm like, I swear it wasn't me, but since I wasn't doing some features as a result, there's no way to prove that it wasn't me. So maybe it was my friends. Maybe it was my peers or coworkers who I pissed off in a code review. Or maybe it was some evil hackers wearing a ski mask, attacking my computer, looking at the photographer. So I say, hey, security, come on over, come take a look. And the whole thing with this distributive model of Git is they're going to immediately ask me, who do you trust? And I'll be like, well, I don't trust anyone, Because, in God we trust, all others must submit a X.509 certificate, or i.e., an SSL cert. Because the interesting part about Git is they solved the, integrity issue by saying, hey, let's use the GPG trust model, where we can inherently trust other people's signatures and how they sign and declare statements when they push or commit. And I could spend a whole hour talking about this model, but think of it this way. We all have neighbors, some we trust, some we would never trust, and we also have exes who no one would ever trust in our circle of trust. So it's very transitive in nature. There are some people you can trust fully, some you can only trust to do certain operations. So it gets very ugly when you start exploring this out to, say, a 200 development man shop. It's quite interesting. Because the sad part about it, or the good part about it, is you only get one signature per commit. There's no multiple people being able to make the same statement, only one person. So you are loaded to the teeth, and sure, put your cheat codes on and everything, you are that link, for better and worse. You can embed the signatures, such as we see Jake and Nuth doing here, with their fun little t-shirt and whatnot. But the typical signature styles, when you commit and say, hey, I authorize this, or I'm stating this, and it's my online identity, is you have 3.5 methods of doing this. You can sign each and every commit, which is pretty nice until you start getting backlogged with hundreds of commits you need to review and sign. So sure, sign each and every one, and then you get to say, yes, I reviewed each and every one of these, and I take the blame in case anything goes wrong. But unfortunately, it's really a hassle. Or you can just quickly sign that merge. Here comes a big diff and all the history behind it. You can just sign that saying, I don't know what all this other stuff is, but I agree to pull it in. It's quick, certainly, but sadly, you're not really doing anything. Or you can just flatten it into one huge patch or diff file. But then again, you'll miss history, and then when people come back to blame you, why did you introduce this defactor bug or backdoor? It'll be like, well, it wasn't me. And they look at the history, and there's no history there. It was you. And the fun part is I say the 0.5 because Google engineers, I don't know what's up with their repo servers, but they're constantly going up and down. So you'll see Google engineers taking pictures of their commit signature, so to speak, and then be like, hey, yep, this is me. I authorize it. And they'll quickly take it down. So it's always entertaining to see that. So which one of those three you want to pick really depends on the outcome that you want. So if you always want the history to be written by the victors, then just flatten it. Let it be what it is. If you want to live on the wild side, just sign the merge commit, and then later on you guys can point fingers. Or you can sign all of the commits, each and every one. But the problem with that is, I don't know about you, but humans are kind of lazy. Like, for instance, I wouldn't want to sit there and constantly have to review each and every one and sign it. I trust my coworkers and others. So I'll just create some signing automation. Very simple, 2-3 lines of bash, and I'll just sign each and every one. So that could be troublesome in its own way, where the control you just implemented kind of failed, but on the other hand, you have someone to blame. But the interesting part is you have to be kind of careful about when you sign. I mean, are you saying that this lady's beautiful, or that there's an old, ugly witch there? So are you saying, hey, I'm committing this, and it's described as the metadata and everything there? Or are you saying the snapshot and commit messages were authored as described in this based on everything else also said in there as well? Or are you saying the diff and commit message was authored as described? For instance, what we see here is someone modifying the sudo-wers file, and they're giving evil hacker passwordless sudo to everything. And the comment is, it's okay, security said so. Okay, sure, that sounds good. So you have to be very careful with what you mean, and you really need to figure that out. So the interesting part is, when I personally like to break into stuff, especially for development purposes, I love it when developers just walk away and leave their computer unlocked. Typically what I do is I change their background to Nicolas Cage and change all of their icons to Cage, to Cage them. Or send fun little lovely thinking of you emails, like, hey, thinking of you. And then we reply back, oh, really? Tell me, what made you think of us? And they're like, that wasn't me. And I'm like, let's sit down and talk. Let's empower you and help you out. But typically, the developers' IDEs are set up to automatically push and pull. Very rarely, especially once they get going, will they have to enter in credentials. Say Perforce, environment variables, username, password, right there for the taking, or in a file. Or same thing with Git, typically uses SSH auth or variations on a theme or a token. So all you have to do is just open up their IDE, introduce your little backdoor, push commit, done. Typically, you won't have to push much more buttons than that. It's interesting. Or I call this the script kiddie hacks. But Git, when you configure your Git environment, it has a few settings you can set, such as my email address and my name. You don't have to verify any of that. So you could say 1 minute, hi, I'm President of the United States at whitehouse.gov. And here's my email address. And then make a commit, and it looked like it came from that person. And then right before you commit, the next time, change it to someone else. Like literally, you can do this over and over again. And another sad thing is, if you really want to be script kiddie evil, you can also change the system clock time. Go up there, right corner, click time, set it to whatever you want it to look like someone was doing in case they were on vacation at the time. Just put in their email address and name and commit. And then later on, they can't argue because the source of truth is there. But one way you can kind of do this is signing those commits, but not everyone will do that. And the interesting part is, during the hacking team leak, they were discussing how to backdoor repos. And they kind of got some things wrong. I mean, they weren't far off, but they were really focused on breaking SHA-1. Now, the reason I bring up SHA-1 is when you make a commit, or you say, here's my code, I authored this, everything's fine, push, there's a tag, or it's called commit message, and that is effectively a SHA-1 hash. Now, the nice part about Git, by design, is that it's temper evident. So if you start mucking around in the history, everything following down to current time will be tamper evident. All those hashes will change, and it will be very obvious what happened when. So the sad part is, if you want to try breaking that hash, it's realistically that a higher probability exists that every member of your programming team will be attacked and killed by wolves on unrelated incidents on that same night. So if you have a really tight tinfoil hat, you should take your development team, rifle shooting and shotgun shooting. But the sad part is, if you look up the Shappening, for about $75,000 on EC2, you can get a SHA-1 collision. Now, mind you, it's very rudimentary. It's not like, oh, look, here's a string. Oh, look, I found a collision for it. No, they're tweaking it some. But most people are saying 2018 is the expected end of life for SHA-1, while many others are saying 2016 now, because now it's getting much cheaper and much quicker. But the good part about Git is when you end up finding that collision, as we see here in these streams, is your original commit, that's all good and hunky-dory is red. And when this new gibberish blue stream comes in, the collision, Git would be like, yeah, I don't care about this new thing. I'm still going to track the old thing. So, yay. But if you still have that really tight tinfoil hat, if you see something that comes in and it looks like gibberish, don't apply it. I mean, it's going to look like weird gibberish hacks. It'll be something very not English or code-like. But the good part is, imagine trying to memorize that SHA-1 hash and try to talk to your development team or peers about it. Like, no one will ever be like, hey, what do you think about 1DB0A39, blah, blah, blah. So, they opted to adopt prefixes, especially many of the popular tools. So imagine here, I updated my GitHub repo, and as we see here, it gives the prefixes. Not the full hash or anything, so people will start talking shorthand or referencing those. Well, Brad Fitzpatrick of LiveJournal fame said, hey guys, here's a Go script where you can take a repository, any commit that you want. Of course, it'll be tamper evident if you go too far back, and just modify the prefix to one of your setting. Just, what do you want the prefix to be? I'll modify it. And chugs through, say on a 2-3-year-old MacBook Air, nothing too special. It should take, depending, say, 5 or 6 character long prefix, 20 seconds? I mean, we're not talking days or millions of dollars. It's actually really short, simple, and sweet. So this is my favorite way to start mucking around with developers, is to be like, hey, oh wait, you mean my prefix? Mine? Oh no, yours? So it's kind of fun. But the sad part is, when we start looking at signing projects in the open source world, see on GitHub, give me everything. The most popular projects that you host publicly. They have over 9,000 stars, which seems like Facebook likes or upvotes on Reddit and others. And it's kind of sad when you think about it. Because what we see here is way up here at the top, you have Linux with 523,000 commits. Okay, sure. But it has roughly 1,000 and some odd signed commits. But you would think, hey, Git, eat their own dog food. They're not really signing at all. They're doing maybe 100 signed commits out of the total 51,000 commits to the repository. Very, very few projects are actually signing their commits. Indicative of either it's hard. What you'll see is many of the keys for the Linux commits are in all of your public, key repositories, MITs, PGPs, and others. Well, very few other projects even make their keys publicly available to really identify who they are, who they say they are. It's sad, but one thing to kind of help bring this along is, I'm not telling you guys, but this scale up here is logarithmic. So if I do that, turn it to a much more linear format, I mean, yes. So yeah, you have GitLab, Ember, Docker, and then Rails, and yeah, it's not a good state. So I don't know exactly why people aren't signing, but as an evil attacker, I like that because it allows me to easily impersonate people instead of having to break others' security models. So this is a security conference. So let's start talking about some O-days and vulnerabilities. So not very scientific research of, hey, I'm just going to search for popular SCMs and just see how many known vulnerabilities there are. So, hey, Secunia, hey, Perforce, 7 total. Okay. SVN, a lot. Most of it's in third-party tools, which you might expect because a lot of them are quite old. Hey, CVS, a lot of stuff in third-party tools. And sure, they have a few core problems, but nothing too bad. Or say Git, 2,000. Now, the interesting part about Git is that a lot of them are actually in Git itself, not third-party software services. The first one here, the case-insensitive file system, kind of makes me laugh because Mercurial, another popular distributive system, had this nasty vulnerability where on case-insensitive file systems, it would not, should I say, work as expected or unexpected behavior. So he looked at Git and others and was like, hey, Git, you're vulnerable too. So, a competitor being like, hey, na, but also, hey, I'm trying to help you out too. So that's quite entertaining. But when I ran CVS and SVN through static source code analysis tools, Fortify and others, they came out perfectly clean. That was intriguing, definitely not expected. But Git had some pretty nasty problems. We're talking 60, 70 resource leaks, memory leaks, things like that. But good or bad part is Git typically doesn't run for that long. So maybe sure denial of service, but more sad is all the null pointers and integer overflows. There's far too many in there, as you guys might imagine. I want to continue to use Git, and I'd have to patch it across my farms, so I'm not going to give you those. But let's take a look at GitLab. It's had some problems in the past. It's a relatively new piece of software built on Rails. And a lot of the vulnerabilities in GitLab is, hey, I'm going to inherently trust this configuration setting or this environment variable and just execute it. No sanity checking, nothing. Okay, that's not really useful, because if I'm able to modify that, I expect I could probably do a lot more easy. So here's a good old, give me any file in the file system. So part of the wiki part of it, hey, sets params, ID, and version ID. Does the file exist? Okay, send it along. They still have yet to patch this, quite sadly. But on the other hand, this is almost way too easy to find. But I guess a lot of people aren't looking. So the interesting part about distributive nature is there's tons of ways you can implement controls within Git. You can write scripts and automation, server-side or client-side. I strongly recommend doing a little bit of sanity checking, more functional on the client side, but don't trust it. Do everything client-side. So as they start to push hook, put some stuff in there and just do some sanity checking, making sure that they are who they say they are. And the entire history list going down there. And I have a few scripts there to help you guys kind of kick that off and adapt it to your processes or tooling. But ultimately, you can't just accidentally introduce backdoors into your app. It's always the tried and true way, still easiest, rubber bats, paying someone off. But also with that, just wait for them to leave their computer or take over their machine. And then just pop it in there. Or if you get access to the central repository, start aliasing commands or hooks. And then when they think they're doing something, they're actually doing something quite else. And there's definitely some ways you can adapt to this within the software development lifecycle, more in the pre-release distribution phase. So that's actually quite useful. But on the other hand, you're still limited by your typical controls of code reviews, items of that sort. So please still keep your other SDLC controls in place. But on the other hand, as an attacker, it's awesome. Because very few people are signing these days. So you just go in there to a machine, you can script kiddie it, and it'll probably get through for better and worse. So thank you guys for coming. Now, two more things. So imagine if you want to be a rock star programmer or, an awesome Stanford professor. There's this awesome Python module called Rockstar. Just say, hey, I'm going to import this Rockstar module, give it a number of days that you want to be a rock star, and say, make me a rock star. It will modify your repository by giving you that many days of commit logs. Cool, right? So, I decided to give myself 50 years worth of commit history, which most of this would predate any modern computer. And so I started getting fun inquiries from recruiters saying, wow, that's really awesome. Do you want to come work for us? How do you keep busy all the time? I'm like, wow, you didn't actually look, because what this module does is it just does hello world and adds and removes it day in and day out. So I was like, okay, thanks. What made you think of me? But another fun thing with GitHub is they have this awesome API that's almost a fire hose of all the public commits. And Ben Cox took a look at this and started pulling all of the SSH keys that people were using to authenticate into and pushing and pulling. And collected a large database and then started going over it. Well, if you might imagine with SSH, typically your keys by default now are 1024, maybe if you're a little paranoid, 2048 or 4096. He was finding keys that were 0256. Very weak keys, and he was like, hey guys, these are easy to reverse. And GitHub didn't really understand the shared responsibility aspects of a service, and they're like, meh, their keys, they generated them, their fault. And he's like, no, really, this is a problem. You need to tell them or start taking corrective action. And they're like, meh. So he put it out there in the public domain, hey guys, look what I found, and here's the entire data set. And then immediately GitHub's like, oh, yep, okay, we start revoking all those keys. So, interesting times. So sometimes you don't even have to go in through the front door. Now, on the other hand, one little last bit of laughter to send you guys off.
AGM tweets, Linus Torvalds is angry. Programmers are angry people. You know what, AGM? Some of the people I work with, you'd be angry too. Ryan Block tweets, Linus Torvalds' crowning achievement, Linux or Git, debate. Why do I have to have just one crowning achievement? I can do both. Pike tweets, apparently Linux dual booting exists because Linus Torvalds wanted to play Prince of Persia on DOS. Pike, not anymore. We've got Steam on Linux now.
So I can't recommend more than enough Pro Git book, a great resource on how to functionally use Git, but how to lock it down and things to be aware of. So thank you guys for coming, and truly, this is the end. If you guys have any questions, you can find me over in the vendor area in the corner over there, and thank you guys. So I'll see you guys all later.